What I'm about to share may change everything you think you know about 3i Atlas, and about what is really happening in our solar system right now. For weeks, mainstream media has debated whether this interstellar visitor is merely an unusually bright comet, a fragment of cosmic debris, or something far more exotic. But leaked documents, classified observations, and testimony from insiders paint a very different picture, one that government agencies seem determined to keep out of public view. Just days ago, a powerful coronal mass ejection from the Sun slammed into 3i Atlas. Under normal circumstances, an object of this size and composition should have been deflected, fragmented, or at the very least destabilized. Instead, what happened next defied every known law of physics. Instead of disintegrating, the object absorbed the energy, the equivalent of 1 trillion nuclear detonations, and re-emitted it as a series of structured, coherent signals. These signals, according to sources familiar with classified intercepts, were not random bursts of radiation. They were directed toward Earth, encoded in patterns that suggest intentional design. Astronomers noted a 40-fold increase in brightness immediately following the solar storm, an increase too rapid and too precisely timed to be natural. This was not the chaotic flare-up of a cometary outburst, but a controlled, deliberate event, as if someone, or something, had switched on a cosmic beacon. No known natural process could account for such precision, leaving scientists and intelligence analysts scrambling to explain the phenomenon. The revelations didn't stop there. Trajectory calculations compiled from 227 observatories worldwide revealed that 3i Atlas has an estimated mass of 33 billion tons, far denser than any typical comet, and, impossibly, denser even than the material inside neutron stars. Yet somehow, despite this extreme density, it is masking its gravitational influence. The mathematics are solid, verified again and again by independent teams, but the implications are staggering. Either our understanding of matter is incomplete, or this object is using technology capable of manipulating gravity itself. Perhaps even more disturbing than the physics is the human response. The 20 researchers who recently went public with their findings were merely the tip of the iceberg. Leaked correspondence suggests that dozens more scientists have been pressured into silence. Careers have been quietly derailed, research grants revoked, and in some cases, access to critical telescopes has been restricted. Whistleblowers describe a coordinated campaign to suppress uncomfortable questions, all while military tracking networks, normally used for monitoring satellites and missile launches, have been repurposed to keep 3i Atlas under constant surveillance, and there is a deadline. The window for whatever 3i Atlas is doing, or planning, closes in weeks, not months. December is repeatedly cited in the leaked documents as a point of maximum significance. This is not speculation or conspiracy theory. It is a conclusion derived from orbital mechanics and mission planning, models so precise they are used for deep space navigation. Whether this represents first contact with an extraterrestrial intelligence, or the prelude to something more ominous, the evidence suggests humanity is about to face a revelation unlike any in its history. Before we explore this extraordinary story in depth, take a moment to reflect. If you're hearing this now, you're ahead of the curve. Share this information, stay alert, and think critically, because the mainstream narrative may not catch up until it's too late. Chapter 1. The 20-Scientist Bombshell, September 19, 2025. An academic paper appeared online that shook the foundations of the astronomical community. Its title seemed dry and technical: Statistical Analysis of Trajectory. Anomalies in Interstellar Object 3i Atlas, but hidden within its dense equations. And careful academic phrasing was a conclusion so extraordinary that it triggered an immediate and ferocious backlash. The paper was signed by 20 researchers from major institutions across 3 continents. Together, they had taken the unprecedented step of asserting, in peer-reviewed form, that 3i Atlas was not behaving like a natural object. Its trajectory, they argued, was too precise, too efficient, and too strategically aligned with planetary positions to be the result of random chance. The lead author was Dr. Elena Vasquez, a planetary dynamics expert from the European Southern Observatory with an impeccable reputation. Her methodology was rigorous, her data carefully verified, and yet her conclusion was nothing short of revolutionary. "The trajectory data is keeping me awake at night," she wrote in an email later released under academic Freedom of Information rules. "We are looking at precision navigation that would make our best spacecraft engineers jealous. This isn't random. This isn't natural, and we need to start having very uncomfortable conversations about what that means." The data spoke for itself. When 3I Atlas was first detected hurtling toward the inner solar system at nearly 200,000 kilometers per hour, astronomers classified it as just another interstellar traveler, a cosmic drifter ejected from some distant star system. But as more observatories tracked its path, patterns emerged that could not be ignored. The object's approach appeared to be targeting 3 major planets: Venus, Mars, and Jupiter, with what the researchers called statistical impossibility. Dr. James Chen, an astronavigation specialist at MIT, struggled to explain the precision in layman's terms. "Imagine throwing a dart from New York and hitting a bullseye in London," he told colleagues. "Then imagine that same dart ricocheting with perfect accuracy to hit bullseyes in Paris and Rome. That's what we are seeing here, except the distances involved are hundreds of millions of kilometers. Each planetary encounter was calculated to maximize data-gathering opportunities while minimizing energy expenditure. Exactly the kind of trajectory human engineers design for spacecraft performing flybys." Dr. Maria Santos, a mission planner at NASA's Jet Propulsion Laboratory, admitted privately that she found the course more elegant than anything we've ever put together in a lab. Even more unsettling was the object's approach vector. Instead of entering the solar system from a random direction, as interstellar objects usually do, 3I Atlas had approached from the direction of Sagittarius, near the galactic center, an area so densely packed with stars that early detection would have been nearly impossible. Some researchers suggested this looked like an intentional choice, a way to delay discovery until the last possible moment. If true, that timing was devastating. Humanity had only a few months to observe 3I Atlas before it would pass behind the Sun, potentially disappearing forever. A longer observation period might have allowed more definitive answers. Instead, scientists were left scrambling to learn as much as they could before the object slipped beyond reach. The academic response was swift and brutal. Within 24 hours of the paper's publication, senior figures at NASA, ESA, and other leading institutions issued public statements questioning the author's conclusions. Press briefings emphasized that 3I Atlas showed clear signs of being a natural comet, including a visible coma and evidence of outgassing. But what critics conspicuously avoided was the math itself. No one challenged the trajectory data, only the interpretation. Meanwhile, the 20 scientists who had signed the paper faced immediate consequences. Dr. Vasquez was called into a meeting with her department chair and warned that her research might jeopardize future funding. Colleagues who had once collaborated closely became distant overnight. Invitations to speak at conferences were quietly rescinded. Similar stories came from Chen at MIT, Santos at JPL, and several others. But these researchers had anticipated the backlash. In private messages, they had agreed that the potential implications were too great to suppress out of fear for their careers. If 3I Atlas was truly an engineered object, humanity deserved to know. The paper spread like wildfire. It was downloaded over 50,000 times in the first 24 hours. Science journalists scrambled to translate its technical conclusions into language the public could understand. Social media erupted with speculation about alien visitors and government cover-ups. Amateur astronomers began running their own orbital analyses using freely available data. And, astonishingly, many confirmed the findings independently. This grassroots verification made it nearly impossible to suppress the story. For the first time in history, the possibility of alien contact had moved from science fiction into peer-reviewed literature. And the world was paying attention. Intelligence agencies quickly prepared classified briefings for government officials, outlining possible scenarios ranging from peaceful contact to existential threats. No matter how the establishment tried to downplay it, the paper had achieved something remarkable. It forced the world to confront a question long relegated to speculation. What if humanity is no longer alone? The scientific establishment had found itself in an impossible position. To publicly acknowledge the validity of the trajectory analysis would have meant legitimizing the possibility that humanity was being visited by a technological intelligence, a step that could trigger social, political, and religious consequences on a global scale. To dismiss the findings outright risked accusations of censorship, of burying data that could represent the single most significant discovery in human history. The chosen solution, at least at first, was silence. Institutions issued no formal retractions but quietly stopped discussing the paper altogether, hoping that without official comment, public interest would eventually fade. But this strategy backfired spectacularly. The silence was interpreted not as caution, but as confirmation, proof, at least in the eyes of the public, that there really was something governments and major space agencies were hiding. Conspiracy theories flourished, some far more dramatic than anything the 20 scientists had dared to suggest. The object was rumored to be a scout ship for an incoming fleet, a weaponized probe meant to test Earth's defenses, even a harbinger of apocalyptic judgment. In the middle of this frenzy, Dr. Elena Vasquez and her colleagues found themselves transformed into reluctant celebrities. Their professional profiles were suddenly flooded with interview requests from podcasters, journalists, and documentary filmmakers. Some offers came with promises of lucrative book deals or speaking tours. Most of the scientists declined, preferring to let the research speak for itself. But their very silence only seemed to make them more intriguing. By early October, 3i Atlas had gone from a niche topic in astronomical circles to a cultural phenomenon. Late-night talk shows debated its meaning, religious leaders preached sermons about its possible significance, and social media platforms were flooded with memes, speculation, and amateur analyses. The object had stopped being just an astronomical curiosity. It had become a mirror in which humanity projected its hopes, fears, and questions about its place in the cosmos. The math, however, remained unchanged. The trajectory analysis did not lie. 3i Atlas was moving with the precision of a spacecraft following a pre-planned route. Whether that precision was the result of some exotic but natural process not yet understood, or the product of deliberate design, was still up for debate. But the comfortable assumption that humanity was alone had been shattered. The bombshell had been dropped. The question now was whether humanity was ready to confront what might come next. Chapter 2. Loeb's mothership theory goes viral if. The 20 scientists had opened the door to the idea that 3i Atlas was something more than a comet. Avi Loeb kicked it wide open. Known for his willingness to challenge orthodox thinking, Loeb had built a career on exploring bold hypotheses that other researchers might hesitate to entertain. As the Frank B. Baird Jr. Professor of Science at Harvard University and the longest-serving chair of the astronomy department in its history, he had earned a unique freedom to speculate without immediately risking his career, even by his standards. However, what he published on his personal blog on August 5, 2025, was extraordinary. The post began with his signature blend of rigor and accessibility, carefully walking readers through the known parameters of 3i Atlas, its size, velocity, and orbital trajectory. Then, in one calmly written paragraph, Loeb dropped a sentence that would reverberate across the globe. The more likely scenario, from an engineering perspective, involves a mothership that releases many probes which perform a reverse Oberth maneuver at perihelion and intercept Earth, taking advantage of the Sun's gravitational assist. That single word, mothership, was enough to ignite a media firestorm. Within hours, screenshots of the post were circulating on Twitter, Reddit, and Telegram. News anchors read the quote on live television. YouTube channels devoted to UFOs and conspiracy theories reported record traffic. Loeb didn't stop at merely suggesting the possibility. He laid out in clinical detail exactly how such a deployment could work. Using standard orbital mechanics, he demonstrated that a main craft could release smaller probes at the moment of closest solar approach, using the Sun's gravity to decelerate them and slingshot them toward the inner planets. According to his models, the probes would arrive at Earth within weeks of release, and that release would take place during the period when 3i Atlas would be hidden from Earth's view behind the Sun. The timing, Loeb emphasized, was not coincidental. If an advanced intelligence wanted to minimize detection, there could hardly be a better moment to act. His calculations identified an arrival window for any hypothetical probes between November 21st and December 5th, 2025. The implications were staggering. Humanity was not just watching a visitor pass through the solar system, they might be witnessing the deployment phase of an engineered mission. Whether that mission was peaceful or hostile remained unknown, but the scenario forced readers to confront an unsettling possibility. Whatever was about to happen, the timeline was short. The reaction was immediate and global. Within 6 hours, Loeb's post had been read 800,000 times. By the end of the day, the number exceeded 2 million. Interviews were requested by major networks, but Loeb suddenly became unreachable. His university email returned automated messages stating he was unavailable for comment. His research assistants claimed ignorance of his location. For NASA, ESA, and other space agencies struggling to maintain a narrative of calm scientific analysis, the timing could not have been worse. Just as they had succeeded in framing 3I Atlas as an exotic but natural comet, one of the world's most respected astrophysicists had suggested that it might be a craft preparing to release probes. Dr. Sarah Mitchell, NASA's director of astrobiology and a longtime colleague of Loeb, was forced to hold a press conference. Professor Loeb's speculation goes far beyond what the available evidence can support, she told reporters. While we respect his contributions, these ideas remain conjecture. But Mitchell's carefully measured tone was drowned out by the tidal wave of public reaction. The hashtag "The Alien Mothership" trended globally for a full week. Emergency food and survival gear sales spiked. Amateur astronomers organized online to monitor the object as closely as possible. Protests erupted in several major cities, with demonstrators demanding government transparency under banners reading, "Tell us the truth about 3I Atlas." Despite the institutional pushback, Loeb's scenario gained credibility as other experts began weighing in. Dr. James Harrison, a propulsion specialist at NASA's Jet Propulsion Laboratory, reluctantly published a peer-reviewed paper confirming that a reverse Oberth maneuver, the very technique Loeb had described, was not only theoretically possible, but would in fact be the most efficient way to insert probes into Earth-crossing orbits. This approach, Harrison wrote, would maximize energy efficiency while minimizing the likelihood of early detection. It represents the kind of elegant mission planning we strive for in our own spacecraft design. Harrison's analysis turned Loeb's blog post from an intriguing thought experiment into a scenario that aerospace engineers could not easily dismiss. Suddenly, what had seemed like science fiction became a technically plausible mission profile. Amateur radio operators soon added fuel to the fire. Around the world, experienced listeners reported strange signals coinciding with 3I Atlas's position. Many were weak, intermittent, and easy to dismiss as noise, but others contained structured patterns. Marcus Chen, a retired engineer from New Mexico, posted recordings to YouTube that quickly went viral. "I've been listening to deep space for 40 years, Chen explained in the video. "This isn't background radiation. It isn't a pulsar. This is organized. This is carrying information." Analysis of Chen's recordings revealed pulses corresponding to prime numbers and Fibonacci sequences, mathematical patterns often proposed as universal signatures of intelligence. Though skeptics argued that coincidences and equipment errors could explain the data, enough independent confirmations poured in to make outright dismissal difficult. Government agencies once again defaulted to silence, a choice that only heightened public suspicion. The result was an unprecedented level of grassroots participation. Online forums dedicated to 3I Atlas exploded in membership, blending professional astronomers, amateur enthusiasts, and conspiracy theorists into a chaotic but surprisingly effective network of distributed observation. By mid-October, Loeb's mothership theory was no longer just one man's speculation. It had been modeled, simulated, and stress-tested by independent researchers around the world. Computer simulations suggested that dozens of probes could be released without altering the main body's course, allowing it to maintain the appearance of a passive object, even while deploying a reconnaissance network across the solar system. Dr. Elisa Park, a systems engineer at MIT specializing in orbital dynamics, published a paper describing how such a deployment could achieve a comprehensive survey of all major planets in a single pass. "The efficiency of this trajectory suggests intentional mission planning," she wrote. "It exceeds anything achievable by current human spacefaring technology." The international response shifted dramatically. Russia called for immediate multinational coordination of tracking and data sharing. China's space agency released unusually detailed orbital data to global partners. Behind closed doors, intelligence briefings grew more urgent. What had begun as a controversial academic paper was rapidly becoming the most closely monitored event in human history. The sudden and unprecedented transparency from China's national space administration raised as many questions as it answered. For decades, China had been famously secretive about its space surveillance capabilities and data-sharing policies. Yet, here they were, releasing detailed tracking information on 3i Atlas to international partners. Analysts and journalists alike speculated about what Chinese scientists might have observed that was alarming enough to justify such a radical policy shift. This was not a nation that made public disclosures lightly. If they were sharing data, it meant they were genuinely concerned, perhaps even afraid. Europe's response was no less dramatic. The European Space Agency convened an emergency session of its Space Situational Awareness program, summoning experts from across the continent. These were not routine meetings. Leaked notes from the closed-door discussions suggested that the agency was quietly drafting contingency plans for managing first contact with an extraterrestrial intelligence, a scenario long considered, the domain of science fiction rather than policy. Whatever conclusions they reached were never made public, but the urgency of the meeting underscored the fact that the mothership theory was no longer a fringe idea. It had become a matter of legitimate concern at the highest levels of scientific and governmental leadership. Meanwhile, social media platforms were pushed to their breaking points as the global conversation about 3i Atlas reached a fever pitch. Algorithm-driven recommendation systems, designed to surface the most engaging content, inadvertently amplified the most dramatic, speculative, and often least accurate theories. Videos claiming that 3i Atlas was a harbinger of invasion received millions of views, while sober scientific analyses struggled to gain traction. Conspiracy theories flourished, weaving together elements of legitimate research with elaborate speculation about government cover-ups, alien diplomacy, and secret military preparations. The psychological toll of this information overload soon became measurable. Mental health professionals began reporting a sharp rise in anxiety-related consultations, particularly from individuals obsessively calculating approach vectors and theorizing about deployment timelines. Online support communities sprang up almost overnight, providing a space for those gripped by what psychologists began calling contact anxiety, the fear that humanity was not ready for whatever was coming. For some, the idea of alien contact was awe-inspiring. For others, it was terrifying. Religious communities also found themselves grappling with questions they had never seriously confronted. Was this event a sign of divine intervention? A test of faith? A challenge to long-held beliefs about humanity's unique place in creation? The Vatican issued a carefully worded statement, acknowledging that the Christian view of creation was vast enough to encompass the possibility of intelligent life beyond Earth, and urging believers not to succumb to fear. Faith should guide humanity through uncertainty, not magnify its dread, the statement read. Other religious leaders were more divided, some proclaiming the event as fulfillment of prophecy, others warning that alien contact represented a spiritual deception. But perhaps the most unsettling aspect of Avi Loeb's analysis was what he called the stealth deployment advantage. In a follow-up post that received even more attention than his original Medium article, Loeb explained that any probes released by 3i Atlas during its perihelion passage, the moment when it would pass closest to the Sun, would be virtually undetectable by Earth's current technology. The solar glare and electromagnetic interference would mask the release event completely. By the time the probes became detectable, he warned, they would already be wherever they were meant to be. This possibility was chilling in its implications. It meant that humanity might already be under observation, and not even know it. Intelligence agencies around the world were suddenly forced to contemplate scenarios for which they had no precedent. National security planners began incorporating the possibility of alien surveillance into their risk assessments. Deep space monitoring networks, originally built to track asteroids and orbital debris, were retasked to operate at maximum capacity. And through all of this, Avi Loeb himself remained conspicuously absent from the public conversation. He canceled all speaking engagements, withdrew from conferences, and his office at Harvard was reported empty. Staff claimed no knowledge of his location or availability. His disappearance only deepened public speculation. Was he being silenced? Was he in hiding? Or was he continuing his research privately, preparing to release even more explosive findings? Whatever the reason, the mothership theory had already escaped into the public imagination, and nothing could put it back. By late September, the sense of urgency had reached a new peak. The window for the hypothetical probe deployment was approaching, and new data was arriving almost daily. That was when Dr. Michael Zhang made a discovery that would push the entire situation into uncharted territory. Zhang, an astronomer at the European Southern Observatory, was conducting routine photometric observations in the early hours of September 27, 2025, when he noticed something profoundly strange. At first, he assumed his instruments were malfunctioning. The readings indicated that 3I Atlas was not just shedding mass like a normal comet, it was physically growing. The object's nucleus appeared to be expanding, developing new structural features that had not been present in previous observations. For 4 tense hours, Yang rechecked his data. He recalibrated his instruments, reviewed his methodology, and compared his readings to archived observations from months earlier. Every test yielded the same result. 3I Atlas was changing. Not in the passive way comets do, sublimating ice as they approach the sun, but in a way that suggested active structural transformation. ESO immediately mobilized its global partners, issuing an alert that brought dozens of major observatories online. The flood of data that followed over the next 72 hours painted an astonishing picture. High-resolution imaging from the Hubble Space Telescope revealed what appeared to be geometric structures emerging from the object's surface, organized, symmetrical formations that no natural process could easily explain. Dr. Jennifer Walsh, an imaging specialist at the Space Telescope Science Institute and one of the more outspoken skeptics of alien interpretations, found herself forced to reconsider. After 18 straight hours analyzing the Hubble data, she appeared before a hastily arranged press briefing and delivered a statement that stunned the scientific world. "We are observing the emergence of structures that exhibit clear geometric organization. These patterns display symmetry, coordination, and growth rates that are not consistent with any known natural process. In plain language, something is building itself out." There, spectroscopic analysis confirmed the structures were composed of materials distinct from the comet's main body, complex metallic, compounds not normally associated with cometary nuclei. Even more shocking, time-lapse photography showed these structures extending and articulating in real time, some of them repositioning themselves as though they were components of a larger coordinated system. Amateur astronomers quickly joined the effort, some capturing their own footage that went viral online. One such video, recorded by Carlos Mendez from his private observatory in Chile, was viewed over 15 million times in a week. "I know what natural cometary activity looks like," Mendez said in his commentary. "This is not natural. This is intentional. We are watching technology at work." The situation escalated further when radio telescopes monitoring 3I Atlas reported a dramatic change in its electromagnetic emissions. Weak, sporadic signals that had been dismissed as background noise suddenly became stronger and more structured, with bursts correlating precisely to each new physical change observed on the object's surface. Dr. Frank Wilson, director of the National Radio Astronomy Observatory, later told a congressional briefing, a transcript of which leaked almost immediately, that the probability of such correlations being coincidental was approaching zero. Computer analysis revealed that the signals contained mathematical sequences, prime number progressions, and even geometric diagrams embedded in the transmission pattern. Most disturbingly, the signals appeared to be directional, aimed at Earth governments around the world quietly, activated contingency protocols originally drafted during the Cold War for managing unprecedented technological threats. Deep underground command centers were brought back to full readiness, and global communication networks were placed under enhanced surveillance. For the public, the impact was electric. Social media collapsed under the strain as images, video clips, and live analyses flooded every major platform. News networks abandoned their usual programming, shifting to 24-hour coverage. Financial markets swung wildly, with technology companies surging on speculation about knowledge-sharing opportunities, while defense contractors saw spikes in demand amid fears of conflict. Religious leaders struggled to respond. The Vatican issued another carefully crafted statement, this time emphasizing that all creation, regardless of origin, is encompassed by divine providence. Other faith traditions were less unified, some framing the event as an apocalyptic sign, others as a new chapter in humanity's spiritual evolution. But perhaps the most important finding came from Dr. Lisa Chen, a systems engineer at MIT, who analyzed the emerging structure's growth patterns. Her preliminary report concluded that 3I Atlas appeared to be constructing a vast sensor array, a distributed network capable of scanning the entire inner solar system. "This is not random," Chen wrote. "It is a deliberate, phased deployment of reconnaissance systems. The object is preparing to observe, map, and perhaps interact with our planetary neighborhood at a level of detail we cannot match." With the deployment schedule apparently accelerating, the question was no longer whether 3i Atlas was natural or artificial. It was what, or who, it was preparing to communicate with. The deployment pattern was far too organized, far too deliberate to be a natural phenomenon. Dr. Chen, an astrophysicist renowned for her meticulous work, documented her findings in a report that was both hastily assembled and rigorously detailed. Her conclusion was simple but staggering. "We are observing the systematic construction of what appears to be scientific instrumentation. It was not just a passing rock," she argued. "This was a machine, and its purpose was unmistakable. The object is studying us with the same intensity that we are studying it," Chen wrote. The implications were almost impossible to overstate. If Chen's assessment was correct, 3i Atlas was not a random alien visitor on a one-way trajectory through the solar system. It was a research probe, a mission designed to gather data, and humanity was its primary subject. This realization changed everything. Humanity was not simply watching first contact unfold from a safe observational distance, they were the experiment. Something had traveled across interstellar space with the specific intention of investigating Earth and its inhabitants. The object's actions were deliberate, structured, and increasingly undeniable. Government officials around the world found themselves facing an unprecedented crisis of communication. How much could they tell the public? How could they inform billions of people without triggering panic? Diplomatic protocols, designed for slow-moving geopolitical disputes, suddenly felt like relics of another age. Events were evolving too quickly for committees and summits. Press briefings became carefully scripted exercises in linguistic gymnastics, statements that acknowledged unusual, astronomical observations while stopping, short of confirming what everyone watching could see for themselves. NASA Administrator Janet Peterson delivered what would become one of the most scrutinized speeches of the decade. In a live primetime address broadcast across the United States and streamed worldwide, she tried to strike a balance between reassurance and honesty. "We are observing phenomena that challenge our current understanding of celestial mechanics and material science," Peterson said, each word weighed as carefully as a diplomat's. "Our commitment remains unchanged to maintain scientific rigor and public transparency as we work to understand what we are witnessing." But behind the scenes, the conversations were very different. Classified briefings painted a far more dramatic picture, one that suggested humanity was facing an encounter that no science fiction author or SETI researcher had ever fully imagined. So 3i Atlas was not behaving like the quiet, passive alien signal that SETI had dreamed of for decades. It was active, it was adaptive, and it was methodically investigating human civilization from a vantage point hundreds of millions of kilometers away. Its surface was no longer inert. Day by day, new structures appeared, growing outward in increasingly intricate patterns. Telescopic imagery showed lattices, towers, and what appeared to be radiating arrays, structures that could not be explained by natural geological processes. Amateur radio operators began reporting strange new signals as each formation came online. The transmission patterns hinted at systematic tests, different frequencies, different modulations, as though the object was scanning the entire spectrum of Earth's electromagnetic output. Some claimed the patterns resembled radar sweeps, as if the alien device was mapping the planet's electronic heartbeat. At this point, skepticism began to erode. What had once been dismissed as sensational speculation now stood as undeniable evidence of a non-terrestrial intelligence. The object had evolved from a curious interstellar interloper into a fully operational platform, and humanity was witnessing it live. And then came the event that changed everything. Chapter 4. CME. Collision, First Contact or Cosmic Accident. The dates of September 24th and 25, 2020 would be remembered as the turning point, the moment when 3i Atlas ceased to be merely a mystery and became undeniable proof that something beyond human understanding was at work. On September 19th, the Sun released a massive coronal mass ejection, CME, a titanic eruption of charged plasma that raced through the solar system at speeds exceeding 1,000 kilometers per second. Though such events are a natural part of the sun's cycle, this one was enormous, unleashing energy equivalent to trillions of nuclear detonations. NASA's Space Weather Prediction Center monitored the CME's path and initially predicted it would pass harmlessly through space, missing all major planetary bodies. But their models did not account for 3I Atlas being directly in its path. Dr. Sandra Martinez, a heliophysicist at the National Solar Observatory, was monitoring the event when her instruments recorded something that made her stop cold. At precisely 14:37 UTC on September 24th, the CME slammed into 3I Atlas. The impact should have been catastrophic. A small, inert object would have been obliterated, or at best, pushed aside like a leaf in a hurricane. But 3I Atlas did not behave like an inert object. Instead of being destroyed, the structures on its surface seemed to come alive. They glowed, expanded, and reconfigured as if responding to the oncoming storm. The object's brightness spiked dramatically, increasing by a factor of 40 until it was visible to the naked eye from Earth. For a brief period, every person on the planet could step outside and see the glowing visitor with their own eyes. But brightness was not the most shocking part. Spectroscopic data showed that the energy absorption was selective. Different wavelengths of radiation were channeled into different structures. The entire process resembled an energy harvesting system, purpose-built to capture and utilize the chaotic power of a stellar storm. This was not survival by chance. It was control. Dr. James Thompson, a Princeton plasma physicist who had spent his career studying solar wind interactions with planetary magnetospheres, admitted in a classified report that the data challenged the most basic assumptions of space physics. The object appears to have actively managed the CME encounter, he wrote. This level of electromagnetic field manipulation and energy control is beyond anything we can replicate. It exceeds our current technology by orders of magnitude. For 4 hours and 17 minutes, 3I Atlas converted the solar storm into organized electromagnetic emissions. Radio telescopes around the globe began detecting structured signals, transmissions unlike anything seen before. They were not random noise, nor were they the simple mathematical pulses that SETI had long speculated might herald first contact. These were rich, multi-layered signals with information density so high that Earth's fastest computers could not decode them. The transmissions were deliberate. They were aimed at Earth. Dr. Alan Foster, director of the SETI Institute, made the historic announcement during an emergency press conference broadcast worldwide. The signal structure demonstrates mathematical precision, information density, and encoding sophistication that indicates advanced technological intelligence. Foster stated, visibly stunned, "We appear to be witnessing information transfer on a scale and level of sophistication that strongly suggests non-terrestrial origin." What followed was the largest coordinated cryptographic effort since World War II. Intelligence agencies, cybersecurity researchers, and mathematicians across the globe worked to crack the code. The results were both exhilarating and terrifying. The encryption used mathematical principles humanity had not yet discovered. Some analysts even suggested the encryption itself was a kind of message, a demonstration of capability, a way of saying, "This is who we are, and this is what we can do." And then came the most unsettling revelation. The signals were not being broadcast aimlessly into space. They were being targeted. Careful analysis revealed beam patterns that focused on Earth's major population centers, communication hubs, and technological infrastructure. It was as if 3I Atlas was performing a detailed survey of human civilization, its networks, its systems, its vulnerabilities. Dr. Maria Santos, a communications theorist at UC Berkeley, published a peer-reviewed paper that shook both the scientific community and global security agencies. "This is not random outreach," she warned. "This is reconnaissance." The world now faced a sobering question. Was this the prelude to a conversation, or to something far more consequential? The transmission patterns were too precise to dismiss as coincidence. Dr. Maria Santos, a communications theory specialist at UC Berkeley, released a peer-reviewed report that, despite heavy redactions, sent ripples through the scientific and intelligence communities. The transmission patterns correlate strongly with global population density, electromagnetic signatures from major urban centers, and the geographic locations of our most advanced scientific installations, she wrote. This appears to represent systematic reconnaissance and data gathering rather than an attempt at peaceful communication. It was a conclusion that chilled even the most seasoned analysts. If Santos's interpretation was correct, humanity was no longer an impartial observer of an interstellar visitor. They were the subject of an ongoing, deliberate investigation, catalogued, mapped, and analyzed by an intelligence that had crossed the void of interstellar space to find them. Governments could no longer treat the phenomenon as a scientific curiosity. The response shifted overnight from open-minded research to urgent national security protocol. Military forces around the globe were placed on heightened alert, with strategic command centers working around the clock to model potential worst-case scenarios. Infrastructure teams were ordered to harden power grids, communications networks, and space-based assets against possible electromagnetic disruption. Contingency plans that had once existed only as classified simulations were quietly activated, some for the first time in history. But while governments scrambled, the public moved faster. The CME collision and subsequent transmissions had been observed not just by official space agencies, but by tens of thousands of amateur astronomers and radio operators worldwide. The genie was out of the bottle. There was no containing the story. Within hours, social media lit up with raw telescope footage, spectrum analysis graphs, and speculative commentary. The hashtag #ChemiCollision went viral, accumulating over 50 million posts in its first 48 hours. Streaming platforms struggled under the weight of millions of uploads as citizen scientists dissected every new development, often publishing their findings before official channels could even schedule a press briefing. One of the most prominent voices in this grassroots movement was Marcus Rodriguez, an amateur astronomer from Arizona whose early tracking data of 3I Atlas had earned him global recognition. His live streams became a kind of unofficial public briefing, attracting millions of viewers as he coordinated a loose but surprisingly efficient global network of observers, academics, and even anonymous insiders. "We're not just passive observers anymore," Rodriguez declared in one of his most widely viewed broadcasts. "We are active participants in the most critical investigation in human history, and we can't rely exclusively on governments to tell us the full truth." This decentralization of information created enormous headaches for authorities. Every significant new observation was shared and analyzed across thousands of independent channels before any government statement could be crafted. Instead of guiding public understanding, agencies found themselves reacting to viral discoveries, their credibility eroding with every delay. Religious and philosophical communities also struggled to process the news. The CME absorption event had been too visible, too widely documented to deny, and its implications were staggering. Pope Francis issued a carefully worded statement calling for calm reflection and reminding the faithful that creation is vaster and richer than we can comprehend, and its mysteries do not diminish the divine. Other faith leaders convened emergency councils to address doctrinal questions that theologians had barely considered. Was humanity still unique in the eyes of God? Did this discovery challenge or affirm long-held beliefs about creation? Meanwhile, military and scientific strategists were focused on a darker set of questions. If 3I Atlas could harvest and redirect the energy of a coronal mass ejection, one of the most violent events a star can produce, what else might it be capable of? Could it manipulate planetary magnetic fields, redirect radiation belts, or weaponize solar output? Dr. Eliza Park, an MIT systems engineer specializing in advanced energy systems, published a technical report that read more like a military threat assessment than an academic paper. The selective energy absorption, real-time electromagnetic field manipulation, and coordinated system responses suggest engineering principles that approach what we would consider fundamental physical limits, she wrote. These capabilities may exceed our current technology by not just decades, but centuries. Her words were not taken lightly. Space agencies worldwide began quietly repositioning satellites to maximize coverage of 3I Atlas's trajectory and to ensure continuous surveillance of its surface structures. Observatories were placed on 24-hour rotation schedules. The object was no longer just a scientific enigma. It was now being monitored as a potential threat. And then came the most disquieting discovery yet. The CME event seemed to have changed 3I Atlas. High-resolution imaging revealed new structural formations emerging almost immediately after the collision, suggesting that the object had not merely survived the solar storm but had used it. The harvested energy appeared to have been redirected into construction, expanding its network of arrays, towers, and radiators. Amateur radio operators reported detecting entirely new classes of signals, transmissions that had not been present prior to the CME impact. The timing left analysts unsettled. Was this an activation event, a power-up, or had humanity just witnessed the object's equivalent of a software update, a moment when previously dormant systems came online? Even more disturbing was the growing suspicion that none of this was accidental. Solar CMEs are frequent, but the precision with which 3I Atlas intercepted this particular one seemed uncanny. Analysts began to question whether the object had deliberately positioned itself to harness the energy of the eruption, implying foreknowledge of solar weather cycles, predictive modeling far beyond anything human science could currently achieve. This possibility fundamentally shifted the conversation from "what is it?" to "what does it want?" Chapter 5. The Impossible Mass, a 33 billion-ton nightmare doctor. Richard Kett had not slept for 3 nights. The South African astronomer, working with Harvard's Avi Loeb and European colleague Peter Vess, had been tasked with compiling a precise dynamical model of 3I Atlas's trajectory using 4 months of continuous data from observatories around the world. What they discovered threatened to upend centuries of celestial mechanics. Simply put, 3I Atlas was not moving the way it should. The object's path showed no measurable deviation despite evidence of substantial mass loss. It was outgassing, shedding material at a rate that should have been producing measurable thrust like a rocket's exhaust. By all known physical laws, this should have nudged its trajectory in a predictable direction, but it hadn't. We analyzed 4,022 positional measurements from 227 observatories worldwide. Clough announced during an extraordinary press conference that would later be described as the moment when the 3I Atlas mystery crossed the threshold into the supernatural. The data spans 4.5 months of continuous observation, providing unprecedented precision. The result is clear. This object is immune to forces that should be acting on it. The Webb Space Telescope had measured the object losing roughly 150 kilograms of material every second, ejected at speeds of 440 meters per second, a force sufficient to noticeably alter its trajectory. Yet the path of 3I Atlas remained a perfect gravitational arc, as though some invisible mechanism were compensating for every force acting upon it. Dr. Maria Gonzalez, a senior celestial mechanics expert at the European Space Agency and once one of the most vocal skeptics of alien interpretations, admitted the data was inescapable. If an object is losing mass at the rate we are observing, and that mass is being expelled asymmetrically, then by the conservation of momentum its trajectory must change, she said during an emergency IAU session. But 3I Atlas shows no such deviation. It behaves as if it is actively negating the forces acting on it. In other words, the object was flying exactly where it wanted to go, as if guided by an invisible hand or a will. The absence of any measurable trajectory change forced scientists to confront an unthinkable conclusion. Either humanity's understanding of physics was catastrophically incomplete, or they were witnessing technology capable of bending the laws of nature themselves. For 3I Atlas to remain perfectly stable while shedding hundreds of kilograms of mass per second, it would need to possess an astonishing, almost impossible amount of mass. The calculations were mercilessly simple, and they left no room for comforting interpretations. The minimum mass required to explain the object's gravitationally perfect trajectory was 33 billion tons. To put that number into perspective, the object, barely 5 to 12 kilometers across, would have to possess a density approaching that of neutron star matter. A single teaspoon of material from its core would weigh as much as a mountain. Such conditions should only exist within the collapsed core of a massive star, under gravitational pressures so extreme that protons and electrons fuse into neutrons. Nothing in the interplanetary medium should be able to sustain such compression. Yet 3I Atlas was not just sustaining it, it appeared to be actively controlling it. Dr. James Mitchell, an MIT physicist specializing in extreme states of matter, was tasked with evaluating whether any known material could account for such density. After 72 hours of frantic modeling, he he delivered his verdict. "We are looking at something beyond natural processes," his report began. "Either this object contains exotic matter states unknown to science, or its internal structure is engineered with a sophistication that exceeds human capabilities by several orders of magnitude." This conclusion created a crisis that rippled far beyond astronomy. If the object really possessed that much mass, its gravitational influence should have been distorting spacecraft trajectories, shifting asteroid orbits, and subtly warping the paths of comets in its vicinity. But no such effects were observed. The data suggested something even more disturbing. Perhaps 3I Atlas was not only dense, but actively masking or controlling its gravitational signature. Such an ability would represent the most radical technological leap imaginable. Gravity has always been humanity's most untamable force, constant and indifferent. The notion that an intelligence could suppress or manipulate it at will forced physicists and military planners alike to reconsider every assumption about energy, motion, and security. Dr. Sarah Kim, an astrophysicist at Caltech and one of the most vocal advocates for taking 3I Atlas seriously, published a rushed but influential analysis outlining the implications of gravitational control technology. "This is the ultimate expression of engineering capability," she wrote. "An intelligence that can manipulate gravity, can reshape planetary orbits, compress or disassemble matter at the atomic level, and access energy sources that dwarf every method known to humanity. Our current models of defense, deterrence, and infrastructure security become irrelevant in such a scenario." The report landed like a thunderclap in defense ministries around the world. NASA's Planetary Defense Coordination Office, originally created to track potentially hazardous asteroids, abruptly shifted into full activation mode. Deep space monitoring protocols that had existed only on paper were executed within hours. The European Space Agency convened an emergency session of their Space Situational Awareness Program, summoning experts in gravitational physics, materials science, and theoretical engineering. The classified conclusions of that meeting were never released, but leaked documents hinted at contingency plans for first contact with technology that might exceed human understanding by millennia. For military strategists, the nightmare scenarios wrote themselves. An object capable of nullifying or altering gravity could potentially disable satellites, disrupt navigation networks, or alter tidal forces on a planetary scale. The very notion of deterrence collapsed when confronted with an adversary that could rewrite the physical rules of engagement. The public reaction was immediate and overwhelming. Social media platforms overflowed with speculation, debate, and panic. The phrase gravity control trended globally for days. Amateur astronomers and independent researchers pored over publicly available tracking data to replicate the mass calculations. To the alarm of authorities, their results consistently confirmed the professional analyses. What had once been the domain of a small cadre of astrophysicists was now an open-source investigation conducted in real time by millions of eyes worldwide. Dr. Lisa Park, the MIT systems engineer whose earlier work had examined the object's structural developments, published a follow-up study attempting to model what kind of internal architecture could support such density. Her paper was as unsettling as it was groundbreaking. Containing exotic matter would require electromagnetic field control, quantum state manipulation, and structural engineering that operates seamlessly from the subatomic scale to the macroscopic, Park wrote. This object's integration of these technologies into a coherent, stable system suggests engineering that approaches the very limits of physical possibility. The conclusion was inescapable. 3 Atlas was not simply a technological artifact. It was an expression of mastery over the deepest workings of the universe. If its builders could manipulate gravity, they were operating on a level where natural forces were as malleable as clay. The gap between human science and this level of advancement was not measured in centuries, but in paradigm shifts of reality itself. The revelation forced religious communities worldwide into theological crisis. For centuries, doctrines had been written on the assumption that humanity's place in creation was unique and central. Now they faced undeniable evidence that another intelligence not only existed, but possessed powers that seemed to border on the divine. Pope Francis issued a carefully worded statement urging calm reflection, reminding the faithful that creation encompasses infinite possibilities beyond human understanding. Other religious scholars scrambled to construct new frameworks that could reconcile such godlike technology with established doctrines. Intelligence agencies, meanwhile, faced an unprecedented challenge. How do you assess the threat level of an entity that can mask its own gravity, control its trajectory with perfect precision, and perhaps even read human reactions in real time? Traditional models of espionage, counterintelligence, and defense planning suddenly seemed like stone tools against an opponent wielding nuclear weapons. Even more alarming were the energy implications. Maintaining such density, manipulating gravity, and operating the intricate systems observed on 3I Atlas would require unfathomable amounts of power. Dr. Robert Chen, a Caltech energy systems specialist, ran the numbers, and his conclusions were as terrifying as they were elegant. The energy requirements exceed anything we can generate or even imagine generating with current technology, he wrote. The most plausible explanation is that the object is drawing power directly from the quantum vacuum, tapping the zero-point energy that underlies space-time itself. If true, this would make the object effectively immortal from an engineering perspective, capable of indefinite operation without fuel. It could travel interstellar space for eons, upgrade and reconfigure itself, and never exhaust its energy reserves. The mass distribution data also revealed something even stranger. The density was not uniform. Instead, mass appeared to concentrate dynamically in specific regions, often corresponding to the areas where new structures were visibly forming. This suggested that 3I Atlas was actively redistributing its exotic matter as needed, reshaping itself at will. Such capability implied real-time control over matter states at the most fundamental level, something indistinguishable from rewriting reality. Then came the signals. Amateur radio operators reported detecting new transmission types within days of the mass revelation. The signals grew more frequent, more complex, as though the object was reacting to humanity's discovery. Some analysts interpreted them as systematic probes, tests of different frequencies and communication protocols, as if 3I Atlas was trying to measure human comprehension, or perhaps even encourage further investigation. This chilling possibility forced governments to confront a new and unsettling thought. Humanity was no longer just observing the object. It was observing us back. The 33-billion-ton nightmare had transformed from a distant curiosity into a mirror held up to human civilization, reflecting back its scientific ambition, its fear, and its determination. By the time September turned to October, there was no denying the reality. 3I Atlas was not a passive wanderer. It was an intelligence that had sought out humanity, cataloged them, and was now responding to their recognition. Its purpose remained unknowable. Its capabilities seemed limitless, and it was still coming closer. Chapter 6. Solar Blackout, the October Disappearance. The object represented engineering so advanced it appeared to blur the line between natural law and technology itself. 3I Atlas was no longer merely a curiosity. It was an existential question posed to the entire human species. Its mass, energy usage, and seemingly deliberate responses to human observation painted a picture of a construct designed with capabilities that approached the theoretical limits of physics. As October unfolded, and the object continued its steady approach toward the inner solar system, humanity's understanding shifted from awe to unease. Each new data point reinforced a single, unsettling conclusion. Whatever intelligence lay behind 3I Atlas was not only observing humanity, but doing so with purpose. And then came the problem no one could avoid: the solar blackout. October 29, 2025, became the day that marked what astronomers would later call the most unnerving and frustrating period in the history of space observation. On this date, 3I Atlas would reach perihelion, its closest approach to the Sun, and would vanish behind the blinding solar disk for nearly 6 weeks. The timing was perfect, too perfect. If an intelligence wished to operate beyond the prying eyes of Earth's telescopes, no moment could have been better chosen. Dr. Jennifer Walsh of the Space Telescope Science Institute had been warning about this inevitability for months. At the final public briefing before the blackout began, she looked grim. "We are about to lose direct visual contact with the most significant object ever detected in space," she said. "For the next month and a half, we will be completely blind to whatever activities 3I Atlas might be conducting behind the Sun." Astronomers were no strangers to solar conjunctions. Mars, Venus, Mercury, even distant spacecraft like Voyager regularly pass behind the Sun from Earth's vantage point. The periods of invisibility are predictable and usually unremarkable. But this was not Mars or Mercury. This was an actively changing object, one that had been growing new structures, emitting complex transmissions and demonstrating what could only be described as technological intent. Its disappearance was not just an observational inconvenience, it was a strategic nightmare. The timing raised disturbing questions. Was this simply orbital mechanics playing out as expected, or had the object's creators planned its approach to exploit this natural cover? Dr. Avi Loeb's mothership hypothesis had already pointed out that perihelion would be the perfect time for deploying smaller craft or making major system upgrades. The intense radiation and electromagnetic noise of the solar corona would mask even powerful transmissions or propulsion burns. Dr. Sarah Kim at Caltech, one of the leading analysts of 3I Atlas behavior, had been working without rest to model possible outcomes. Her classified report, which was eventually leaked to the press, offered little comfort. The solar blackout provides perfect operational cover, she wrote. Any technological deployment, trajectory modification, or reconnaissance activity conducted during this period would be effectively invisible to all Earth-based observation. The implications were staggering. If 3I Atlas was hostile, this was the window during which it could prepare whatever action its creators intended. If it was peaceful, then this was when it might be performing its most detailed survey of the solar system and human activity. Either way, humanity would know nothing until the object re-emerged weeks later. Possibly changed, possibly closer, possibly no longer alone. NASA's Planetary Defense Coordination Office suddenly found itself in uncharted territory. Traditional asteroid monitoring relied on continuous tracking to predict future positions and evaluate impact risks. But 3I Atlas was not a rock following a simple gravitational trajectory. It was an active participant in its own journey. What emerged from the far side of the Sun might not even be the same object that disappeared behind it. Space agencies scrambled to salvage what little observation was possible. NASA and ESA redirected radio telescopes to listen at the solar limb, hoping to catch stray transmissions peeking around the edge of the Sun's interference. The European Space Agency went further, taking the extraordinary step of repositioning several of its deep space monitoring satellites. The maneuvers would consume precious fuel reserves, shortening their operational lifespans, but the intelligence value was judged worth the cost. Russia's Roscosmos initiated its own classified maneuvers, quietly retasking military satellites to monitor regions of space just outside the solar glare. Leaked documents later revealed that Russian analysts were especially concerned about trajectory changes, evidence of active to propulsion that would confirm beyond doubt that 3I Atlas was under intelligent control. China's National Space Administration, continuing a policy of rare openness, released highly precise predictions for when the object should reappear if it maintained its current path. Their data gave the international community a clear timeline. If the object failed to appear within that window, then something, perhaps something deliberate, had changed. Meanwhile, the global community of amateur astronomers, who had played such a crucial role in tracking and analyzing the object's earlier behavior, braced for what would be the most agonizing period of their lives. For months, they had been providing near real-time updates, often beating official agencies in identifying changes in the object's structure and emissions. Now they would be forced to wait, staring at a patch of blinding light in the sky, powerless to see beyond it. Public anxiety surged as news networks counted down to the blackout. Social media was flooded with speculation. Was this the moment the object would unleash probes toward Earth? Would it deploy weapon systems? Would it simply vanish forever, leaving humanity with unanswered questions? Governments quietly activated emergency contingency plans. Communication infrastructure was hardened against electromagnetic interference. Military commands were placed on heightened alert. Some nations even moved key satellites into standby modes, fearing potential disruptions. The United Nations Security Council held closed-door sessions nearly every day in the final week of October, but no consensus could be reached on how to prepare for what might come next. The day of disappearance arrived under a heavy, global silence. The last images of 3I Atlas, captured by the James Webb Space Telescope just hours before it crossed the solar limb, showed something remarkable: new massive structures forming along its surface, glowing faintly as though radiating stored energy. Whatever it was doing, it was preparing for something, and humanity would not see the result until December. For 6 long weeks, the world waited. Every transmission from deep space was analyzed for anomalies. Every unexplained blip in the data became the subject of frantic debate. Religious leaders called for prayer and reflection. Stock markets swung wildly as investors tried to anticipate whether the object's reappearance would herald disaster or a new era of contact. When November passed with no further information, the tension became nearly unbearable. Humanity had been thrust into the greatest cliffhanger in history. The question was no longer merely scientific. It was personal, existential. What would emerge from behind the sun? Would it be the same object? Or would humanity face something transformed by its solar passage? Something even more incomprehensible than before. By mid-December, telescopes were aligned, detectors primed, and the entire planet seemed to hold its breath. Whatever came next would change everything. The sudden loss of visibility marked a profound turning point in humanity's experience of 3I Atlas. The final days before solar conjunction carried a strange sense of ritualistic gravity, as though the entire planet was preparing for a collective vigil. For months, every new observation had revealed additional layers of mystery and complexity, until the object no longer seemed merely an astronomical phenomenon, but rather a participant in some cosmic drama. And now, just when the mystery had reached its most tantalizing point, 3I Atlas would slip behind the sun, beyond sight, beyond measurement, beyond verification, leaving humanity to wrestle with its own imagination. The psychological weight of this event was unprecedented. Scientists, journalists, and ordinary citizens alike felt the gnawing unease of enforced ignorance. "We have been watching this thing as if through the eye of a needle," Dr. Jennifer Walsh had remarked at her final press conference. And now, for 6 weeks, the needle will be gone. The metaphor resonated across media outlets, symbolizing not just the loss of observational capacity, but also the existential discomfort of waiting for something unknown, something powerful, something possibly dangerous to emerge from the other side. Around the globe, observatories captured their last images before the object became engulfed by the sun's glare. The final frames were haunting. 3I Atlas appeared larger and more structurally complex than ever before. New protrusions, scaffolding-like formations, and what some astronomers cautiously described as antenna-like arrays jutted from its surface. The object no longer resembled a simple nucleus of rock and ice. It had become something unmistakably engineered, or at least something whose evolution suggested purposeful modification. These last glimpses fueled a fresh wave of speculation. What was it building? Was it preparing for acceleration, communication, or something entirely beyond human comprehension? Amateur astronomers were among the most deeply affected. For months, they had been the unsung heroes of the global monitoring effort, their distributed network of small telescopes filling in gaps between major institutional observations. Now they too would be rendered blind. Marcus Rodriguez, whose Arizona observatory had become a hub for these citizen scientists, addressed the community in an emotional live stream that quickly went viral. "We may not be able to see 3I Atlas directly," he told his viewers, "but the universe is never completely silent. If it moves, if it emits energy, if it interacts with the solar wind, we may catch its fingerprints on the environment. We will not stop watching." His words became a rallying cry, inspiring thousands of new volunteers to join the makeshift network he had organized to monitor the solar corona for any subtle disturbances. This citizen effort marked one of the most remarkable collaborations between professionals and amateurs in modern science. Solar observation was no trivial task. It required expensive filters, precise tracking systems, and meticulous safety protocols to prevent eye damage or equipment failure. Yet the passion of these observers overcame practical barriers. Thousands of images of solar prominences, coronal mass ejections, and subtle fluctuations in brightness were uploaded daily to shared databases. Professional solar physicists found themselves analyzing terabytes of amateur-collected data, astonished at both its volume and its quality. "We are living through the most intense period of solar observation in human history," remarked Dr. Lisa Santos of the National Solar Observatory, "and much of the data is coming from people who had never studied the sun before last month." the blackout also produced ripples far beyond the scientific community. Social media platforms exploded with speculation, memes, countdown clocks, and elaborate theories. Some groups treated the event with near religious solemnity, referring to the hidden weeks as a cosmic Sabbath. Others succumbed to apocalyptic dread, convinced that 3I Atlas would emerge from behind the sun, either as a weaponized invasion fleet or not at all, implying catastrophic destruction before reappearance could occur. Anxiety support networks reported surges in membership as people struggled to cope with the sense of helplessness. The feeling that humanity was being watched, judged, or tested weighed heavily on the global psyche. Religious communities responded in profoundly different ways. In some traditions, the blackout was interpreted as a sign of divine testing, a cosmic trial requiring patience and faith. Special prayer services were organized in churches, mosques, synagogues, and temples around the world, uniting billions in quiet contemplation. For others, the event carried apocalyptic resonance. Prophecy groups pointed to ancient texts that described a hidden sun or a silent star as omens of transformation. Even secular societies felt the symbolic weight of the moment, as if history itself were holding its breath. Economic systems were not immune to the tension. Stock markets became whipsawed by fear and speculation. Technology companies saw valuations spike as investors bet on future knowledge transfer, hoping that first contact might lead to breakthroughs in energy or propulsion. Defense contractors likewise experienced volatility as analysts debated whether conventional weapons would be useless against a technology capable of manipulating its own orbit. Governments quietly prepared for every scenario, from public panic to potential mass evacuations, even though no credible threat had been detected. Contingency plans for information management were drafted to combat the flood of conspiracy theories that would inevitably arise in the information vacuum. Within the scientific world, the timing was particularly cruel. Research projects hastily assembled in the preceding months were just beginning to yield meaningful data, only to be interrupted by the blackout. Laboratories were forced into hiatus. Funding agencies hesitated to commit further resources without knowing what 3I Atlas might do. For some researchers, this pause was unbearable. Dr. Elena Vasquez, whose groundbreaking paper first identified the object's anomalous trajectory, admitted in a televised interview, "We have spent months proving that this object demonstrates intelligent behavior. Now we must wait to see what that intelligence does when it knows we are unable to observe. It feels like a cruel experiment, as if we are being deliberately excluded from the most important part of the conversation." The intelligence community took the situation equally seriously. Surveillance networks originally designed to track ballistic missiles and spy satellites were redirected to monitor space near the solar limb. Even so, experts admitted that only the strongest radio transmissions could possibly be detected through the sun's electromagnetic haze. Anything subtle, the release of small probes, structural reconfigurations, trajectory corrections, would remain completely invisible. "This is the longest surveillance blind spot in history," one intelligence analyst commented anonymously, "and it's happening with the most potentially consequential object we have ever encountered." Theories multiplied as to whether the blackout's timing was intentional. Some scientists argued that it was simply an artifact of celestial mechanics, a coincidence with no strategic implication. But Dr. Robert Kim at Stanford, employing game theory models of first contact, reached a more provocative conclusion. If 3I Atlas is controlled by an intelligent agency, he wrote in a widely circulated paper, then it would certainly understand the psychological impact of 6 weeks of enforced ignorance. Whether or not the timing was originally intentional, the opportunity would be too valuable to waste. The blackout maximizes psychological leverage while maintaining complete operational security. Indeed, the last images before disappearance suggested that something significant was underway. Structural development had accelerated dramatically. Some features seemed to be symmetrical, like paired modules or arrays designed for energy collection. Others appeared transient, as though scaffolding was being erected only to be dismantled later. "It's behaving like a construction site," one observer commented. If true, then whatever 3I Atlas was building would be completed in secret, hidden by the blinding glare of the sun. When it re-emerged weeks later, it might be profoundly different from the object humanity had first encountered. As the final hours of visibility ticked away, telescopes across the globe captured their last precious frames. The images revealed an object on the threshold of transformation, slipping into the corona like a diver entering dark water. When it emerged, the world would see what it had become. But until then, humanity could do nothing but wait. The growing structures and technological enhancements were now unmistakable, their details captured in astonishing clarity by the highest resolution imagery humanity could muster. These final images before the blackout provided a crucial baseline for comparison when 3I Atlas eventually re-emerged. From behind the sun, scientists knew that what they were seeing was not simply a passive object drifting through space, it was evolving, transforming itself before their eyes as though in preparation for something monumental. Global institutions, anticipating the psychological shock of 6 weeks without observation, began coordinated public education campaigns explaining the nature of solar conjunctions and the reasons behind this inevitable disappearance. Television specials, live-streamed lectures, and infographics circulated widely, attempting to reassure a nervous global population that this was not the end of the story, only a pause. Yet for all the rational explanations, nothing could entirely quiet the gnawing anxiety. Humanity understood that during this window, the most extraordinary object in recorded history would be entirely unobserved, conducting unknown activities beyond the reach of every telescope, probe, and sensor array. This was not simply an astronomical event, it was a planetary psychological experiment. For the first time, humanity was being forced into a period of collective ignorance about an event that might define the species' future. The realization struck deep. Social media posts were filled with metaphors likening the blackout to a curtain falling between acts of a cosmic play. "We are not just observers," one commentator wrote. "We are participants who have been asked to leave the theater during the most critical scene." As October 29th approached and 3I Atlas moved steadily towards solar conjunction, the entire planet seemed to hold its breath. Governments issued statements urging calm. Stock markets braced for turbulence. Spiritual leaders spoke of the need for faith, patience, and humility. The next 6 weeks would test not just humanity's scientific ingenuity, but its capacity to remain cohesive and rational in the face of the unknown. Chapter 7. Trajectory Truth. The 0.05% coincidence. For Dr. James Chen, the numbers were undeniable and chilling. As the lead trajectory analyst on the MIT team monitoring 3I Atlas, Chen had spent months running calculations, verifying models, and cross-checking data. The conclusions he reached were not the product of sensationalism or speculation, but of pure, relentless mathematics. And those numbers told a story that was nearly impossible to accept. 3. Atlas was not merely passing through the solar system. It was following a course so precise, so deliberately optimized, that chance could be virtually ruled out. Chen's findings were first presented in a classified briefing, hastily organized for senior officials from NASA, the Department of Defense, and the National Science Foundation. Standing before a wall of projected data, Chen delivered the verdict that no one wanted to hear. We are looking at a combined probability of roughly 0.005% that a randomly arriving interstellar object would follow this precise series of planetary encounters, he explained. Statistically speaking, you are more likely to be struck by lightning while simultaneously winning 3 separate lotteries than to observe what we are witnessing by coincidence. The precision of the trajectory was staggering. According to Chen's calculations, 3I Atlas would pass Venus at a distance of just 0.22 astronomical units, an ideal distance for atmospheric and surface mapping without risk of gravitational capture. Its earlier Mars approach had been equally exact, bringing it within 0.19 AU, a perfect compromise between observational resolution and navigational safety. The most extraordinary maneuver, however, lay still in the future. A March flyby of Jupiter at 0.36 AU, positioned to take full advantage of the gas giant's immense gravitational field. This encounter would allow 3I Atlas to alter its outbound velocity with extraordinary efficiency, effectively slingshotting itself back toward interstellar space. To Dr. Sarah Mitchell, NASA's Director of Mission Planning, the trajectory read like the work of a genius mission designer. This represents navigation and scientific planning that exceeds even our most advanced capabilities, she admitted in an internal NASA meeting later leaked to the press. The path maximizes data collection while minimizing energy cost, and it uses gravitational assists in ways we ourselves have only attempted with our most sophisticated robotic probes. Even more unnerving was the fact that the trajectory did not merely optimize for planetary encounters. Careful analysis revealed that it also provided ideal vantage points for observing asteroid belt objects, Kuiper belt bodies, and numerous smaller systems throughout the solar neighborhood. The course seemed designed to wring every last drop of scientific value from a single pass through the solar system. And then there was the approach vector, the part that disturbed scientists the most. Unlike typical interstellar objects that arrived from random directions, 3I Atlas had approached along a path from the direction of Sagittarius, near the galactic center, where the starfield is so dense that early detection becomes extremely difficult. Dr. Maria Santos, a stellar dynamics expert at Berkeley, published an analysis showing that an object on this path would remain effectively invisible until it was well inside the orbit of Jupiter. This approach vector minimizes detection windows, Santos wrote, while still allowing maximum time for observation once discovered. Timing analysis revealed another layer of precision. 3I Atlas had entered the solar system during a period of unusually low solar activity, avoiding the disruptive electromagnetic storms of solar maximum. The planetary alignments during its approach were nearly perfect for reconnaissance, allowing sequential flybys with minimal course corrections. It's as if someone selected the most scientifically valuable, least risky window for an observational mission, Chen remarked grimly. Dr. Robert Kim of Stanford applied game theory models to the data and produced an even more provocative interpretation. This is not merely an optimized scientific mission, he wrote in a widely discussed paper. It is an intelligence operation. According to Kim, the path showed evidence of operational security planning, minimizing the likelihood of early detection, maximizing data gathering opportunities, and timing its solar conjunction to occur just as human observational interest reached its peak. This trajectory gives its controllers maximum information about us while giving us minimal ability to respond, Kim concluded. The implications were difficult to overstate. If 3I Atlas represented a hostile intelligence, its reconnaissance mission would be complete before humanity could take any defensive action. If peaceful, its elegance suggested a level of technological and cultural sophistication that dwarfed human civilization. What troubled some researchers most was not the efficiency but the beauty of the path. Dr. Jennifer Walsh observed that the ratios between key orbital parameters bore striking harmonic relationships, like notes in a musical composition. There is an aesthetic dimension here, she said in one of her more philosophical public briefings. This is navigation as an art form, an orchestration of celestial mechanics that achieves maximal result with minimal effort. We are looking at intelligence that finds beauty in gravitational dynamics. Such observations opened deep philosophical questions. Could an intelligence capable of seeing orbital mechanics as art also possess motives humans might never comprehend? Religious scholars and theologians weighed in, debating whether this represented evidence of divine design, cosmic kinship, or something far stranger. Even the amateur astronomy community found themselves grappling with the implications. We're not just watching space rocks anymore, Marcus Rodriguez declared in one of his increasingly popular broadcasts. We are watching a mind at work, a mind that thinks in orbits, resonances, and gravitational harmonies. And that mind is using our solar system as its canvas. The realization was staggering. 3I Atlas was not only here by design, it was performing an exquisitely choreographed dance through the solar system, one that might have been centuries or millennia in the making. What it would do after emerging from behind the sun was anyone's guess. But one thing was clear: when it reappeared, humanity would never look at the sky the same way again. Some world leaders interpreted the breathtaking precision and elegance of 3I Atlas's trajectory as nothing short of divine inspiration. Religious scholars from multiple traditions suggested that perhaps this object was a messenger, a creation of higher powers meant to remind humanity of its small place in the cosmos. Others, however, viewed the implications through a much darker lens. If 3I Atlas truly represented intelligence beyond Earth, an intelligence that could surpass human comprehension not only technologically but also philosophically and aesthetically, then humanity might be confronting a reality that would shatter its most deeply held spiritual, scientific, and cultural assumptions. The trajectory analysis had also begun to provide new insights into the likely origin and mission duration of 3I Atlas. By backtracking the object's path through galactic space, researchers suggested it may have traveled for millions, perhaps tens of millions, of years before reaching the solar system. This raised staggering questions about its builders. What kind of civilization launches a probe, or crewed craft, on a mission that would not yield results for geological timespans? Was this a civilization so patient and long-lived that million-year missions were considered routine? Or had they developed self-sustaining technology capable of indefinite operation, continuing a mission long after its creators had vanished or evolved into something else entirely? Dr. Lisa Park of MIT led the technical assessments that attempted to answer these questions. Her work focused on the energy requirements necessary to sustain a functional spacecraft across such immense time frames. Her calculations suggested that 3I Atlas must possess energy sources far beyond anything humanity could currently engineer, perhaps tapping into zero-point energy, nuclear isomers, or some as-yet undiscovered method of power generation that could operate for millions of years without external refueling. Even more provocative was her hypothesis that the object might be self-repairing, capable of replacing or regenerating components as they degraded. We are looking at engineering that treats million-year mission timelines as if they were trivial planning considerations, she wrote in her widely cited report. This level of technological maturity approaches the theoretical limits of what is physically possible. This revelation sparked intense debate among both scientists and military strategists. The patience and persistence implied by such a mission suggested strategic thinking that dwarfed anything in human history. Human civilizations rose and fell in centuries, occasionally millennia. Here, however, was evidence of intelligence willing to play a game whose timescale exceeded humanity's entire recorded history. Defense analysts were forced to develop entirely new models of strategic planning to account for an intelligence that could act over spans so vast that deterrence in conventional military responses became meaningless. Even more alarming was what the trajectory revealed about 3I Atlas's apparent knowledge of human space surveillance capabilities. Its approach path exploited known gaps in Earth's early warning systems, passing through sectors of the sky that were poorly monitored. Its timing also seemed optimized to minimize observation opportunities, arriving during periods of reduced solar activity that improved its ability to gather data without interference. To some analysts, this suggested that preliminary reconnaissance of Earth had occurred long before the object's discovery, perhaps centuries earlier, allowing its planners to design a mission that would avoid detection until the very last moment. Reports from amateur radio operators deepened the mystery. As the object approached each planetary target, several groups detected unusual transmission patterns, bursts of narrowband signals that correlated almost exactly with 3I Atlas's closest approaches. These were not random emissions. The timing and frequency shifts suggested active data collection and transmission, as if the object was compiling observations and relaying them either to itself, to onboard storage, or, more chillingly, to a distant receiver somewhere in interstellar space. The conclusion was becoming inescapable. 3I Atlas was not simply wandering through the solar system. It was carrying out a meticulously planned reconnaissance mission, one designed with precision and forethought. As October progressed, 3I Atlas neared its carefully choreographed encounters with Venus and Mars. Each maneuver confirmed the extraordinary planning sophistication behind its trajectory. The so-called 0.05% coincidence, the probability that a random interstellar object would achieve such perfectly timed planetary flybys, could no longer be dismissed as luck. Humanity was being systematically observed by a probe whose capabilities and intentions remained maddeningly opaque despite months of observation, modeling, and analysis. By late October, the scientific debate had reached a fever pitch. Chapter 8 of the unfolding story, which commentators were now calling the Dark Forest chapter, marked a turning point in human intellectual history. The scientific community, which had long prided itself on its commitment to rationality, peer review, and evidence-based discourse, suddenly found itself in uncharted territory. The 3I Atlas crisis was no longer a purely academic question. It was becoming a confrontation with existential uncertainty. What began as collegial debate quickly escalated into intellectual warfare. Careers were on the line, and entire research programs were threatened by the implications of one interpretation or another. On one side of the divide were the so-called naturals, scientists who insisted that 3I Atlas must be a natural object, no matter how unlikely its trajectory appeared. They pointed to the human tendency toward pattern recognition and warned against leaping to conclusions about extraterrestrial intelligence. Their opponents, the artificials, argued that the data could no longer be explained by random processes. The precision of the trajectory, the optimization of energy use, the apparent signaling activity, and the calculated exploitation of Earth's surveillance blind spots all pointed to a deliberate mission of artificial origin. Dr. Christopher Hayes, chair of the International Astronomical Union's Commission on Interstellar Objects, found himself at the center of this escalating conflict. As one of the first to publicly suggest that 3I Atlas might represent extraterrestrial intelligence, he had become both a hero and a villain, depending on which side of the debate one stood. Funding agencies began to prioritize research proposals that aligned with one or the other perspective, and heated arguments spilled out of academic conferences into the public sphere. The controversy intensified after the publication of several groundbreaking papers exploring the so-called dark forest hypothesis. Originally proposed by Chinese science fiction author Liu Cixin, the hypothesis suggested that advanced civilizations might deliberately remain silent and hidden out of fear that any signal revealing their location might attract the attention of hostile species. Applied to 3I Atlas, the theory painted a chilling picture. What if this object was not a friendly probe, but a silent observer, dispatched by a civilization that treated the universe as a dangerous and predatory place? What if its purpose was not to make contact, but to decide whether humanity was a potential threat? The possibility rattled even the most skeptical researchers. If the dark forest hypothesis were true, then contact with other intelligences was not a matter of cultural exchange, but of survival. The universe might be filled with watchers, each waiting for the other to slip, to reveal their position, to expose their vulnerability. And humanity, by broadcasting television signals, radar sweeps, and interstellar messages for nearly a century, might already have given away its position to whoever, or whatever, had sent 3I Atlas. Dr. Adam Hybard, a senior researcher at the Initiative for Interstellar Studies in London, co-authored one of the most controversial and unsettling papers on the dark forest implications of 3I Atlas's behavior. Collaborating with analysts Adam Kra and Avi B., Hybard approached the object's trajectory not as a matter of neutral scientific curiosity, but as a potential act of deliberate, strategic reconnaissance. The team's work applied intelligence-gathering models and military planning theory to what had previously been considered a purely astronomical problem. The dark forest hypothesis, Hybard wrote, suggests that any intelligence capable of interstellar travel would approach unknown civilizations with extreme caution, assuming the worst until proven otherwise. The safest approach is to remain silent, observe from a distance, and evaluate whether the newly discovered civilization represents a threat. Their paper, published in a leading astrophysical journal, argued that 3I Atlas's path through the solar system fit this model disturbingly well. The behavior patterns we observe, Hybard concluded, are consistent with reconnaissance activities that could precede either peaceful first contact or, in the most pessimistic scenarios, preemptive elimination of a potential rival intelligence before it grows dangerous. This framing shook the astronomical community. Defense think tanks and military planners quickly began citing the paper in classified briefings, and the scenarios it outlined were grim enough to keep senior defense analysts awake at night. If 3I Atlas truly represented an advanced reconnaissance probe, then humanity might not be on the brink of interstellar friendship, but under quiet evaluation for possible elimination. Its systematic survey of planetary bodies, its ability to avoid detection until late in its approach, and its optimized trajectory were no longer seen as idle curiosities, but as data points in a threat assessment protocol. The reaction from the academic establishment was swift and, in some cases, brutal. Senior astronomers from NASA, ESA, and other major institutions issued joint statements condemning what they called irresponsible speculation. They argued that Hibbard and his colleagues risked inciting public panic over what was still, in their view, a largely natural phenomenon with no confirmed evidence of intelligence. The backlash did not merely challenge Hibbard's conclusions, it questioned whether publishing such papers was ethically defensible at all. Was it responsible to suggest without proof that humanity might be under threat from an alien probe? Or was such transparency necessary to prepare society for the possibility, however remote, that 3I Atlas might not be benign? NASA's lead scientist for solar system small bodies, Dr. Margaret Thompson, became the public face of this institutional resistance. Standing before a wall of microphones at a live televised press conference, she declared, "The suggestion that 3I Atlas represents hostile alien intelligence is not supported by the available evidence. Speculation of this sort risks undermining public trust in science and distracting us from the careful observation and analysis that are still underway." But Thompson's careful, measured statements were quickly undermined by a whistleblower leak. Internal communications revealed that NASA and the Department of Defense had, in fact, begun quietly drafting contingency protocols for potential alien contact scenarios. Some of these documents explicitly reference the possibility of hostile reconnaissance. The leak ignited a second wave of controversy. Why were space agencies publicly dismissing the possibility of alien intelligence while privately preparing for it? For Dr. Elena Vasquez, the scientist whose early trajectory modeling had first hinted that 3I Atlas's path was too precise to be random, the situation was a nightmare. Caught between institutional caution and the growing dark forest faction, she attempted to carve out a middle position. "The data suggest intelligence," she said in one of her increasingly rare public appearances. "But intelligence does not necessarily imply hostility. We must distinguish between evidence-based conclusions and the speculative scenarios built on top of them." The controversy soon turned into what historians would later call the academic war. Younger researchers, less burdened by institutional politics and with careers still to build, argued passionately for open discussion of every possibility, including hostile scenarios. Senior scientists, worried about public panic and institutional credibility, urged restraint, emphasizing uncertainty over speculation. Dr. Sarah Kim at Caltech became a rare voice attempting to bridge the widening chasm. Her papers acknowledged that 3I Atlas demonstrated technological capabilities far beyond human reach, but she cautioned against projecting human concepts like friend or enemy onto something that might not share human cognitive frameworks at all. "We are confronting an intelligence that operates according to principles we may not even be capable of understanding," Kim wrote. Attributing human motivations to such a mind, whether hostile or benevolent, may be fundamentally inappropriate. We may be dealing with an entity for whom our categories of morality and strategy are meaningless. This philosophical approach drew interest from outside the hard sciences. Anthropologists, linguists, psychologists, and philosophers began weighing in, bringing perspectives that questioned whether humanity was even equipped to interpret what it was observing. Dr. Maria Santos at UC Berkeley published a paper on contact linguistics and xenopsychology, warning that humans might be trying to interpret alien behavior through frameworks that were entirely inadequate. The dark forest hypothesis assumes that alien intelligence would think strategically about threats in ways similar to human military planning, she wrote. But this assumption may be completely invalid. We are trying to understand minds that may have evolved under utterly different pressures and may operate under logics we cannot access. This widening of the debate made consensus all but impossible. If human concepts were too limited to interpret alien action, then neither the optimists nor the pessimists could claim confidence in their interpretations. Religious scholars soon entered the fray as well. Some faith leaders framed 3I Atlas as evidence of divine will, a cosmic messenger designed to humble humanity. Others saw it as a test, a moment for humanity to demonstrate wisdom, restraint, and moral clarity in the face of the unknown. The Vatican's Pontifical Academy of Sciences released a carefully crafted statement acknowledging the possibility of non-human intelligence but asserting that divine authority remained supreme over any created beings. Other faith traditions scrambled to develop their own theological frameworks for contact, some welcoming the object as a sign of cosmic fraternity, others warning that it could represent a test of faith or even a deception. Meanwhile, The academic war spilled out of journals and conferences and onto social media. Twitter threads, live-stream debates, and YouTube explainer videos turned once obscure scientists into reluctant celebrities. Accusations of fear-mongering, careerism, and intellectual cowardice flew back and forth. Some exchanges became so heated that university administrators were forced to issue formal guidelines reminding faculty of professional conduct expectations. Public interest only grew as the debate became more polarized. Social media algorithms amplified the most dramatic clashes, often portraying legitimate scientific disagreement as chaos or proof that experts don't know what they're talking about. Citizen scientists and amateur astronomers began taking sides, forming online factions aligned with the naturals or the artificials, the optimists, or the dark forest advocates. Forums dedicated to 3i Atlas became battlegrounds where hard data analysis was interwoven with philosophical speculation about the future of humanity. Some users began posting elaborate what-if scenarios describing how an alien reconnaissance probe might evaluate human military capability, political stability, and technological potential. Military analysts added fuel to the fire when several released declassified assessments treating 3i Atlas as a potential security risk. Colonel Janet Rodriguez, a Department of Defense strategist specializing in emergent threats, published a report that focused not on intentions but on capabilities. Whether 3i Atlas represents peaceful scientific exploration or hostile reconnaissance is ultimately irrelevant to defense planning, Rodriguez wrote. Its demonstrated capabilities exceed our ability to respond. Prudence requires that we plan for scenarios in which such capabilities could be used against human interests. This blunt assessment added urgency to what had been, until then, mostly theoretical debate. Intelligence agencies began quietly recruiting top scientists into classified advisory programs, creating a parallel network of research that operated beyond public scrutiny. This secrecy fragmented the academic community further. Some researchers refused to participate in classified work, believing that open science was humanity's best hope of understanding the situation. Others accepted the call to national service, believing that withholding sensitive analysis from the public was a necessary precaution. Dr. Robert Kim at Stanford publicly declined an invitation to join one such classified effort. In an interview that went viral, he warned that classifying data about 3i Atlas would erode public trust and stifle the very openness science required to function. The moment we hide our analysis behind closed doors, Kim said, we lose our ability to separate evidence-based conclusions from speculation driven by fear. His stance earned him praise from transparency advocates but also criticism from those who believed some information was too dangerous to release. The debate now touched not just on astronomy but on ethics, public trust, and the very role of science in a time of potential existential crisis. By the time October arrived, the dark forest hypothesis had transformed from a fringe speculation into a major intellectual and policy issue. The world was no longer treating 3i Atlas as a curiosity. It was now seen as a potential turning point in the history of the species. The academic war over its interpretation would continue, regardless of what the object eventually revealed. And then came October 3rd, the day of the Mars flyby. For the first time in history, multiple spacecraft from different nations coordinated to observe an interstellar object as it performed what appeared to be a deliberate planetary reconnaissance pass. 3i Atlas approached Mars at precisely 0.19 astronomical units, exactly as predicted by trajectory models. Dr. Sarah Chen, Mission Operations Director for NASA's Mars Reconnaissance Orbiter, oversaw what became the most ambitious multi-spacecraft campaign ever attempted. We have 6 active missions around Mars, 2 surface rovers, and multiple deep space telescopes all focusing on this single object for a 12-hour observation window, she explained during the final pre-flyby briefing, ESA's Mars Express. Orbiter was repositioned to maximize its viewing angle, and its high-resolution stereo camera was tasked with capturing detailed imagery of 3i Atlas's surface. Mission Principal Investigator Dr. Angela Martinez described the plan with barely contained excitement. With our current configuration, we will achieve pixel resolutions of roughly 30 kilometers across the object's surface, she explained. We may be able to resolve individual structures and watch them change in real time. NASA's MRO, with its high-rise camera, would go even further, achieving resolutions as fine as 3 meters per pixel. For the first time, humanity would have a chance to look directly at the surface of an interstellar visitor with a clarity capable of distinguishing its smallest visible features. The world held its breath. Chapter 9. The Mars Flyby. Humanity's first close look. We're about to see the individual components of whatever technology this object represents. Dr. James Wilson declared during the final pre-flyby briefing, his voice carrying both scientific excitement and the weight of global anticipation. If there are artificial structures, mechanical systems, or surface modifications, HiRISE will document them with unprecedented clarity. This single statement seemed to encapsulate the significance of what was about to occur. For the first time in human history, multiple spacecraft from different nations would observe an interstellar visitor at close range while it actively engaged in what appeared to be systematic reconnaissance of another planet. This was not a fleeting glimpse of an object passing through the solar system. It was a carefully coordinated observational campaign designed to capture every possible detail of a phenomenon that had already forced scientists, governments, and philosophers to rethink their place in the cosmos. The Mars flyby had catalyzed a level of international cooperation that many observers had once thought impossible. Agencies that had previously guarded their data with near-paranoid secrecy were now sharing real-time information through secure international protocols. NASA, ESA, Roscosmos, and the China National Space Administration agreed to provide one another with immediate access to imagery, spectroscopic data, and telemetry. Even India's ISRO and Japan's JAXA contributed their deep space assets to maximize coverage. This event has unified us in ways that go beyond science, remarked Dr. Sarah Chen, Mission Operations Director for NASA's Mars Reconnaissance Orbiter, MRO. For 12 hours, every eye humanity can turn toward Mars will be watching the same thing, the same object, the same mystery. We may not agree on what it is or what it means, but we are all committed to finding out together. MRO, normally tasked with studying the Martian surface in exquisite detail, had been reprogrammed for a different kind of mission, tracking a fast-moving interstellar object at a precision level never before attempted. The spacecraft's high-rise camera, capable of resolving objects as small as 3 meters across from orbit, had been configured to track 3I Atlas as it made its closest approach. If the object carried external structures, rotating assemblies, or surface features suggestive of technology, HiRISE would capture them. ESA's Mars Express orbiter had been repositioned weeks earlier to optimize its line of sight. Its high-resolution stereo camera and onboard spectrometers would collect complementary data, producing a three-dimensional view of the object's surface and its spectral fingerprints. This will allow us to resolve structural components and monitor any activity during the encounter, said Dr. Angela Martinez, the mission's principal investigator. If it is performing active reconnaissance, we should be able to observe operational behaviors directly, maneuvers, scanning patterns, or energy emissions. China's Tianwen-1 orbiter and Zhurong rover added unique capabilities to the campaign. The orbiter's medium and high-resolution cameras would provide continuous monitoring from an orbit synchronized to maximize observation time, while Zhurong's surface instruments were repurposed to look skyward, capturing data from Mars's surface as the object passed overhead. The level of transparency demonstrated by China, sharing observation sequences and data-sharing agreements ahead of time, was seen by many as a diplomatic milestone, a gesture that underscored the unprecedented nature of the situation. Even Russia, historically guarded about its space operations, committed its Mars orbiters and Earth-based assets to provide continuous coverage. This is the most significant astronomical event in human history, said Dr. Dmitry Volkov, director of the Institute for Space Research, during a rare public interview. No single nation possesses sufficient resources to fully comprehend what we are observing. International cooperation is not just desirable, it is essential. Beyond government space agencies, the event galvanized the global amateur astronomy community. Marcus Rodriguez, an engineer turned citizen scientist who had become a leading figure in public observation efforts, organized a worldwide network of coordinated amateur telescopes. Though these instruments could not match the resolution of orbital spacecraft, They provided redundancy and independent confirmation of major events. If there's a transmission, a sudden change in brightness, or an unexpected maneuver, we'll see it, Rodriguez explained in a live stream viewed by tens of thousands. Preparations extended beyond optical observation. Deep space radar and tracking networks, normally tasked with guiding spacecraft or detecting potentially hazardous asteroids, had been retasked to track 3I Atlas with unprecedented precision. The global network of radio observatories, from Arecibo's successor facilities to the giant dishes at Goldstone and Effelsberg, were synchronized to listen across the full electromagnetic spectrum. Dr. Frank Wilson at the National Radio Astronomy Observatory developed a monitoring protocol that would scan everything from low-frequency radio waves to high-energy microwave emissions. If it communicates with Earth, with its creators, or with some unknown recipient, we will detect and record it, Wilson promised during an international coordination call. The phrase carried quiet implications that many participants avoided stating aloud. Humanity was not just observing. It was listening for signs that might confirm or rule out the most unsettling possibility of all, that they were being actively studied. Military analysts had their own objectives. Frameworks were developed to evaluate the object's scanning patterns and energy emissions, not just for scientific insight but for intelligence purposes. The U.S. Department of Defense, the European Space Operations Center, and China's military space program were all monitoring 3I Atlas as if it were an adversarial reconnaissance platform. Whether it represents peaceful science or hostile surveillance is irrelevant, said Colonel Janet Rodriguez in a classified assessment later leaked to the press. Its demonstrated capabilities exceed our own by several orders of magnitude. Prudence requires that we prepare for scenarios in which those capabilities could be directed against human interest. This convergence of scientific and military priorities added an unmistakable layer of tension to the flyby. If 3I Atlas performed maneuvers consistent with intelligence gathering, or if it emitted signals directed toward Mars's surface installations, the implications would be immediate and profound. Contingency protocols were in place to secure Mars assets, redirect communication arrays, and prepare public statements in the event of an overt technological demonstration. Dr. Lisa Park at MIT had developed a behavioral analysis framework to interpret whatever 3I Atlas might do during its encounter. Rather than focusing on technologies that might be beyond human comprehension, Park's approach emphasized operational choices, how the object distributed its time, which parts of Mars it observed, whether it changed velocity or orientation during key moments. Even if we cannot decipher the specific technologies involved, she explained during a pre-flyby media briefing, we can infer its priorities by watching what it chooses to do. Time is a universal currency. How it spends that time will tell us what it values. As the hours ticked down to closest approach, the atmosphere within mission control centers around the world grew electric. Engineers double-checked software updates, scientists reviewed observation schedules, and international data-sharing links were tested repeatedly to ensure seamless coordination. The sense of collective focus was palpable, not just within space agencies but across the globe. Social media platforms carried live streams of pre-flyby briefings to millions of viewers. News anchors spoke in hushed, measured tones, aware that the public was treating this like a moment out of history. A lunar landing, a Voyager encounter, and a Cold War summit all rolled into one. The difference was that no one knew whether what humanity was about to witness would inspire awe, fear, or both. The Mars flyby was no longer just a scientific event. It had become humanity's first opportunity to study, in real time, what appeared to be alien intelligence engaged in deliberate, systematic exploration. It was, as one commentator put it, the closest thing to first contact we've ever experienced. The question that lingered in every mind, from the control rooms of NASA to living rooms across the world, was simple and profound. Would 3I Atlas simply pass by as a silent observer, or would it reveal something about its purpose, perhaps something that humanity was not yet ready to hear? The psychological impact of witnessing 3I Atlas conduct a reconnaissance mission of another world was profound, shaking humanity in ways no purely scientific discovery ever had. The mere idea that this interstellar visitor, an object of technological sophistication beyond anything humanity could yet build, was actively surveying Mars, forced people everywhere to confront a sobering truth. If it could study another planet, then Earth itself might already have been under observation for years, perhaps decades. This realization struck at the heart of humanity's sense of security, making the planet feel more vulnerable than ever before. Religious communities across the globe responded with a wave of spiritual preparation. Prayer services, meditation circles, and reflection gatherings were organized to coincide with the precise timing of the Mars flyby, turning the astronomical event into a planetary moment of ritual significance. Many faith leaders saw the encounter as a sign, a message, or even a divine test, calling on their followers to ready their hearts and minds for what might come next. Whether viewed as a moment of cosmic revelation or a warning from the heavens, the event was framed as an opportunity for spiritual growth and reflection. Humanity, they argued, was being invited to see itself not just as a collection of nations, but as a single, fragile civilization on a pale blue dot under observation by an intelligence far greater than its own. The media preparation for the flyby was unprecedented. Major global news networks coordinated live coverage across continents, planning continuous broadcasts that would carry viewers from the countdown to the final data transmission. Journalists and science communicators spent weeks preparing explainers, interviews, and simulations to help the public understand what they were about to witness. Interest levels rivaled those usually reserved for the inauguration of world leaders, the landing of astronauts on the moon, or the outbreak of major wars. Social media platforms braced for record-breaking activity, scaling up server capacity and content moderation systems to handle the expected surge. Analysts predicted that billions of people, possibly half of the human population, would follow the event in real time, making it the single most watched scientific milestone in human history. Behind the scenes, the technical preparation was staggering. Coordinating spacecraft across vast interplanetary distances had required months of planning and flawless collaboration between space agencies worldwide. Navigation specialists calculated precise pointing requirements for each orbiter and telescope involved, ensuring that every instrument would be in the right place at the right time to capture data during the narrow observation window. Communication engineers established real-time data relay protocols, allowing observations from Mars, Earth orbit, and ground-based observatories to be combined into a coherent global monitoring effort. No risk was too small to plan for. Redundant systems were built into every stage of the observation campaign. Backup communication pathways were activated to guard against signal loss. Emergency protocols were written in case 3i Atlas performed an unexpected maneuver or exhibited behavior that could be interpreted as hostile. Engineers simulated scenarios ranging from benign data dropouts to worst-case failures of key observing spacecraft. Every step reflected a sense of collective determination. Humanity would not miss this chance to learn. Among the most tantalizing questions was whether 3i Atlas was aware of being observed, if its behavior changed when under scrutiny, if it adjusted its orientation, altered its emissions, or responded in a way that seemed deliberate. Then it would confirm suspicions that it possessed not only intelligence but situational awareness on a scale rarely attributed even to advanced AI. Dr. Robert Kim at Stanford University had developed specific analysis protocols to detect subtle behavioral changes, algorithms designed to separate random variations from purposeful action. If this object is as intelligent as its trajectory and emission suggest, Kim told his colleagues, it will know we are watching. It may even choose to communicate by altering its behavior in ways we can detect. Governments treated the flyby as a moment of existential importance. World leaders cleared their schedules. Intelligence agencies and military commanders placed surveillance networks on heightened alert, not because they expected an attack, but because they recognized the potential implications if the visitor demonstrated capabilities that could affect Earth or its satellites. Diplomats quietly opened back channels with rival nations to ensure that misinterpretations would not lead to accidental escalation. Humanity, for one brief moment, behaved as though it truly was a united planetary civilization, preparing to meet another intelligence. As October 3rd approached, anticipation reached a fever pitch. Humanity braced for a revelation that could change its understanding of life, technology, and its place in the cosmic hierarchy. The next 12 hours, scientists warned, might provide the clearest evidence yet of alien technology operating in real time. evidence that could answer questions humanity had asked for millennia while posing entirely new ones. It was at this moment, with the world's eyes turned to Mars, that Dr. Jennifer Walsh made her extraordinary discovery. Walsh, senior imaging specialist at the Space Telescope Science Institute, had spent 6 consecutive hours poring over Hubble Space Telescope data from July 21, 2025. What she found defied every principle of cometary physics she had been taught. The Hubble images revealed something impossible. The dust trail of 3I Atlas was pointing in the wrong direction. Traditional comet tails always form as solar radiation and the solar wind push gas and dust away from the nucleus, creating a luminous tail that points directly away from the sun. But 3I Atlas displayed what Walsh termed an anti-tail, a teardrop-shaped cocoon of dust that was oriented toward the sun instead of away from it. The broader, more luminous end of the teardrop faced the solar glare, while the narrow end streamed behind the object as it traveled through space. Walsh called an emergency briefing to present her findings. This configuration is aerodynamically and gravitationally impossible under natural conditions, she explained to the stunned room. The orientation suggested that 3I Atlas was not merely venting material, but actively controlling it, as though collecting or manipulating the dust rather than passively ejecting it. The implications were staggering. This was not just a visitor. It was a machine performing operations on a planetary scale. Dr. Sarah Mitchell at NASA's Goddard Space Flight Center was tasked with finding a natural explanation. For weeks, her team ran intensive simulations, modeling every conceivable mechanism: solar wind effects, electromagnetic field interactions, gravitational perturbations, even exotic sublimation processes, but none could account for the observed configuration. In her classified report, later leaked to Congress, Mitchell concluded, "No known natural process can produce the dust orientation documented by Hubble. The evidence is consistent with active, controlled emissions." Initially, the discovery was classified to allow time for authorities to craft a careful public response. But the secrecy unraveled quickly. Amateur astronomers began reporting their own observations of the anti-tail using backyard telescopes and inexpensive imaging equipment. One of them, Chilean observer Carlos Mendez, captured images that confirmed the phenomenon and posted them online. His YouTube video explaining the results went viral, surpassing 20 million views in its first week. "I've been photographing comets for 15 years, Mendez said. "This is not normal behavior. We are watching something actively manage its own emissions. Physics says this shouldn't be happening, and yet it is." The amateur confirmation created a public relations crisis for space agencies that had been attempting to control the narrative. The democratization of astronomy meant that official suppression was no longer possible. Within days, the anti-tail became a worldwide topic of discussion, fueling speculation, awe, and fear. Computer models showed that maintaining an anti-tail structure would require continuous energy input, real-time adjustments, and force control at a level suggesting breathtakingly advanced technology. Dr. Robert Kim published a paper estimating that 3I Atlas might be expending energy equivalent to multiple small nuclear reactors simply to keep its dust structure stable against solar forces. "We are witnessing active engineering of the local space environment," he wrote. "This is technology operating on a scale that makes our most advanced projects look like toys." The energy management implications were sobering. If 3I Atlas could casually expend that much power merely for aesthetic or structural reasons, what might it achieve if it chose to focus its full capabilities on more purposeful tasks? The thought sent chills through military planners and theologians alike. Religious leaders debated the meaning of what they were seeing. Some saw the anti-tail as a form of cosmic art, evidence of a mind that found beauty worth expressing even across interstellar distances. Others feared it as a demonstration of power, a sign that humanity stood in the presence of a force capable of reshaping matter and energy at will. The world waited, breath held, for the Mars flyby, an encounter that might confirm once and for all whether 3I Atlas was merely a silent traveler or something far more deliberate, an emissary, a probe, perhaps even a herald of things to come. The Vatican's Pontifical Academy of Sciences issued a carefully worded statement shortly after the Hubble images were confirmed. acknowledging that divine creativity might manifest itself through intelligences far beyond human understanding. Their message was measured but profound, emphasizing that no technological display, no matter how advanced, could ever threaten the authority of the divine or the spiritual truths that guide human existence. This was a subtle but crucial message. Humanity must learn to see alien intelligence not as a threat to faith, but as part of a wider divine creation. For many, this was reassuring. For others, it opened new philosophical questions about the nature of God's plan and whether humanity was truly at the center of the cosmic story. Other religious traditions were forced to confront entirely new theological challenges. Some denominations held emergency councils to debate the spiritual implications of meeting a species, or machine, that could manipulate matter, energy, and celestial dynamics with apparent ease. These were not abstract debates. The anti-tale had become more than a scientific curiosity. To many believers, it looked like a message painted across the solar system in glowing dust, a cosmic calligraphy beyond their ability to read. Theological frameworks were being rewritten in real time, and clergy scrambled to guide their followers through a period of awe mixed with existential fear. The anti-tale discovery also shed light on something more unsettling: how governments and space agencies had been managing information about 3I Atlas from the very beginning. The initial decision to classify Hubble's findings suggested that the authorities were deeply concerned about the psychological impact of the data on the general public. Internal communications, later leaked, revealed heated debates among NASA administrators and international space policy officials about how much of the truth should be shared. One faction argued for full transparency, warning that withholding information could destroy public trust and create conspiracy theories. Another group feared that revealing the full extent of 3I Atlas's technological capabilities could trigger economic shocks, mass panic, or even religious unrest. Caught in the middle of this institutional struggle was Dr. Elena Vasquez, the brilliant astronomer whose trajectory analysis had first suggested that 3I Atlas might not be a natural object at all. As the lead author of the seminal paper that introduced the object to the world, Vasquez became a symbol for both sides of the transparency debate. Scientists and journalists pressed her for information, while agency officials quietly urged her to withhold certain details until official briefings could be coordinated. Appearing at a rare public forum, Vasquez delivered a statement that captured the tension of the moment. "Scientists have an obligation to share their findings with the broader community," she said, "but we also have a responsibility to consider the implications of information that might cause unnecessary alarm." The anti-tale phenomenon represents technology so advanced that it may be fundamentally beyond public comprehension. We must be cautious. While her words were carefully chosen, they only deepened the sense that humanity was peering into mysteries that might never be fully understood. Meanwhile, the anti-tale itself continued to evolve. Over the course of weeks, it grew more elaborate, developing filament-like substructures and patterns that appeared to shift with mathematical precision. Spectroscopic analysis revealed that different regions of the dust contained distinct material compositions, arranged in what appeared to be systematic order rather than random distribution. Dr. Maria Santos at UC Berkeley published a groundbreaking paper suggesting that the anti-tale might not be merely aesthetic but informational. Her research indicated that the patterns contained repeating ratios, prime number sequences, and fractal geometries, hallmarks of information encoding. The anti-tale configuration demonstrates organizational principles that are too ordered to be accidental, Santos wrote. We may be witnessing a form of communication that uses cosmic dust as a medium for transmitting data across interstellar distances. This was an astonishing hypothesis. If correct, it would mean that humanity was not merely watching a machine behave in a way they did not understand. It was attempting to say something. The challenge was deciphering whether that something was an invitation, a warning, or simply a statement of presence. Adding to the mystery were reports from amateur radio operators around the world who claimed to have detected faint electromagnetic emissions that seemed to correspond with changes in the anti-tale structure. The emissions were not random noise. Their frequency and modulation patterns correlated with moments when the dust configuration shifted dramatically. This raised the possibility that 3I Atlas was broadcasting information in multiple formats simultaneously: visual, electromagnetic, and perhaps others not yet detected. like a multilingual beacon designed to be interpreted by different types of intelligence. Perhaps the most provocative observation was that the anti-tail seemed to become more complex as human instruments improved their resolution. When ground-based telescopes began to produce higher quality images, the dust configuration appeared to rearrange itself into even more intricate formations, almost as though rewarding the effort with additional detail. This uncanny responsiveness suggested that 3i Atlas might be aware of being watched and was deliberately adjusting its display to match human observation capabilities. This possibility disturbed intelligence agencies. If 3i Atlas had been monitoring humanity long before its official discovery, then its artistic displays might not be random demonstrations but carefully chosen messages designed to be deciphered only when human technology reached a certain threshold. Intelligence analysts began treating the anti-tail not merely as a curiosity, but as potential intelligence data. Cryptographers, behavioral psychologists, and military analysts were brought into the effort to analyze the patterns for possible strategic meaning. The Defense Intelligence Agency established a classified task force to examine the anti-tail from the perspective of psychological operations. Their findings, leaked months later, concluded that the phenomenon could be seen as a demonstration of power, a subtle but undeniable statement of technological dominance. Whether this represents communication, intimidation, or simple artistic expression, the underlying technological implications are identical from a security perspective, wrote Colonel Sarah Martinez, who headed the military's 3 Atlas assessment team. Her reports, unusually lyrical for military documents, noted that she was effectively writing art criticism in the context of a threat assessment. Religious communities worldwide responded to the deadline passage in ways that reflected their diverse theologies. Some leaders interpreted the lack of dramatic contact as confirmation that divine authority remained unchallenged by any alien presence. Others suggested that contact might be happening in spiritual, not technological forms, through inspiration, visions, or cosmic events not yet understood by science. The Vatican issued a carefully worded statement acknowledging that divine plans operate on timescales far beyond human comprehension, while emphasizing that the pursuit of truth through scientific observation remained a sacred duty. The impact of the December deadline also rippled through education systems. Universities and schools that had rushed to design curricula for a post-contact world found themselves reassessing what preparedness really meant. Dr. Maria Santos at UC Berkeley conducted one of the first studies on how students were psychologically affected by the build-up to the deadline. Her findings revealed that students who had spent months expecting imminent technological revolution shifted their priorities toward adaptability and critical thinking rather than narrow technical specialization. The most valuable preparation for an uncertain future, Santos concluded, is cognitive flexibility, the ability to think clearly in the face of unprecedented challenges. The business and financial sectors experienced the deadline as both a crisis and a stress test. Stock markets fluctuated wildly, pricing in scenarios that ranged from technological utopia to planetary-scale economic collapse, although relief followed when no obvious alien intervention occurred. The episode exposed structural vulnerabilities in global financial systems, weaknesses that might prove catastrophic if a truly disruptive technological event ever occurred. Amateur astronomers, emboldened by their role in the December observations, continued to operate their telescopes and citizen science networks. They had tasted the importance of their contributions and were unwilling to relinquish their role in humanity's cosmic watch. Some began pioneering new techniques to detect faint or transient phenomena that might escape traditional professional observatories. These grassroots efforts acknowledged a sobering possibility. Advanced alien technology might be designed to remain subtle, conducting reconnaissance below the threshold of obvious detection. Intelligence agencies, too, treated the entire experience as a learning opportunity. The December crisis served as a live-fire exercise for testing capabilities against threats that were not merely technological but potentially beyond human comprehension. New frameworks for threat assessment were developed, focusing not only on weapons and capabilities, but on entirely new modes of behavior and strategy. These analytic tools, designed for cosmic rather than terrestrial security, would remain relevant regardless of whether 3i Atlas proved hostile, friendly, or indifferent. Mental health professionals documented a wide spectrum of psychological responses to the deadline's passing. Some individuals experienced intense relief, others deep disappointment, and still others a kind of lingering existential unease. Support groups originally formed to help people cope with contact anxiety gradually transformed into communities exploring what it meant to live in a universe where alien intelligence was no longer hypothetical. This shift suggested that humanity's psychological adaptation to cosmic reality was no longer a temporary process, but an ongoing part of collective life. As the year came to a close, astronomers prepared for the reappearance of 3I Atlas from behind the Sun, where it had been hidden for weeks. Its emergence offered the first chance since October to determine whether the object had changed, whether it had deployed secondary probes, upgraded its systems, or altered its structure. Early observations were startling. 3I Atlas showed new structural features and more complex electromagnetic emissions than before, indicating active operations during its hidden period. Whatever this object was, it had been busy while beyond human view. Dr. Jennifer Walsh of the Space Telescope Science Institute summed up the mood at the renewed observation briefing. We're about to get our first real look at what this object accomplished during 6 weeks of complete operational privacy. The changes we observe may finally reveal whether this is reconnaissance, research, or something we haven't even imagined. In the end, the verdict on 3I Atlas remained elusive. It clearly represented something unprecedented. Technology or phenomena that forced humanity to rethink assumptions about intelligence, physics, and the very nature of reality. Whether it heralded a new era of cosmic contact or simply exposed the limits of human knowledge, its presence had already reshaped civilization. Humanity now watched the skies with new seriousness, aware that even in silence, the universe was speaking, and perhaps waiting for us to learn how to listen.